Okay, students, now we will start with the second part of risk and return. Okay, let me start with some review from the first part. First of all, I have explained the about the expected cash flows, and second one is the expected rate of return, yeah, with the symbol like this, CF bar or X bar. Alright, and also we have learned about the expected risk. Okay, this is from the single investment. Single investment means one security investment and given with the rate of return, yeah, of every single condition. So we also have some probability of the economic condition. I is the economic condition. Also given some CFI or XI. Yeah, this is given. Right. Okay, and also remember about the required rate of return, which comes from the risk-free rate of return, where this is the return for the treasury security, okay, and this one is the risk premium. So this is the required rate of return of a security from a company, okay, company security. Right, now this is the rate of return. Okay, so again, in financial management, we will face um, um, more than one symbol, yeah, or what more than one definition or more than one term for some definition or understanding in financial terminology. So here I would like to introduce you, beside of K as the rate of return, we also say an R as the rate of return. Okay, well, this is the review from the previous one. Now I will start now with the okay, we have learned about the risk from the previous part, that risk from one or single investment. Okay, now investment, can we avoid that? No, we cannot avoid this. No, yeah, but we can reduce the risk. Reducing the risk through what we call with portfolio. So portfolio means that you invest in in more than one security, more than one security. Okay, so how we describe that we can reduce the risk by using the portfolio. So here we see the diagram of the portfolio risk and the number of stocks in portfolio. So you see here, if I put here 1, so it means one stock. This only stock will give a risk in here. So this is a very high risk. And if I add more than one stock, yeah, then the risk become such a we see here that the risk here have a gentle decreasing on the value of its risk, okay, until it go asymptote with some line here. Do you guys still know what asymptote means? This is the asymptote. Asymptote is the line when there is no graph will crossing the line. Because of what? It's going very near to the asymptote line. So this is the limit of the line. Why do we have some kind of asymptote risk over here? Because you know, I have told you about the unavoidable risk that I have mentioned when I explain about the risk-free or rate of return. Yeah. So in every country, it has their own risk. Okay. So therefore, there is here there is always a risk in a country. So it cannot be avoided, but if we will facing that minimum risk. Yeah, we would like to face the minimum risk of a country. So that minimum risk called with the undiversifiable market risk, or with a simple word, systematic risk. Okay, so this systematic risk is given. Yeah, so we make a diversification through a portfolio because we want to eliminate the unsystematic risk over here. So it goes almost near to the systematic risk. So this is why the portfolio is very important. And the theory is introduced by Markowitz. Theory of portfolio introduced by Markowitz. Okay. All right. Now I want to tell you about another story. Well, not another story, but the extending of our story. Remember when we talk about the expected rate of return, yeah, the K over here, and it is given with some Ki with some condition of economic, okay, and you see that it is given, yeah, the K. Now, how can we measure the K over here? First of all, I will introduce you how to measure the K through the capital gain. We call this as the capital gain. Capital gain is the return that we get from the difference of the ask and buying price from the stock or from the security. So for example, if today I buy one security for 1,000 and tomorrow the price become 1,100, then it means that I will have a profit of 100, right? So that is the capital gain. We call that as capital gain. And how we measure the return or the percentage of from 100 over the 1,000? We use this. K is actually P of tomorrow minus price. Okay, P as price. Yeah, P is price. P of today divided with P of today. Correct? So what I have told you before, I buy today 1,000 and tomorrow is 1,100. So my profit is 100, right? Comes from the 1,100 minus 1,000. So the K will be like this. P tomorrow minus P today divided with the P today. Okay, P tomorrow divided with P today minus P today. I'll separate the denominator for each nominator over here. Yeah, it's the same with this one, right? And then so then it becomes P tomorrow divided with P today minus, look, P today divided with P today is 1. So the same with here. Yeah, tomorrow, if I say tomorrow is T and today is tomorrow minus 1 day, T minus 1. Okay, so we call that as capital gain, or the holding period return in month. The term for this statement is capital gain. Alright, so you can calculate that the T as the day, or T as second, or T as minute, or T as month, or T as year, whatever you like to calculate. T is the period. Right. So I recall again the K, yeah, the rate of return K over here, small k, P, T. Look what I did here. I lowering the T here because it is the name of the, what kind of P is that? Minus 1. So P is the price and T is the time period. Well, whatever you want to calculate, it can be daily, it can be a day, day, and it could be what did I say before? Month, or second, minute, year, etc. Yeah. So now, for example, only for example, if we, so you see that the price is moving, yeah, every second it's moving. Okay, so now say that the price is moving per month, so every month it's moving. Then how do I calculate the monthly the average return of 1 year, say 1 year of stock? Okay, so it just the average return, the average of K, again K is the same, yeah, K bar. Or now I will change, okay, average return come from the K of first month plus K of second month, K of the third month, K from the fourth month, until K from the 12th month, I mean December, January to December. So what is the end of this month then? 12, right? So here is 12. So you see here, this K1 goes to K12. So what can we conclude with this kind of statement? We can say as a formula, this is the sum for every return from a month in a year. So the sum of the period 1, which is month, 2, sum period n, K, I, or I change that with R because I don't want to make a confuse with the R before, even though this is the same, yeah, R and K. Ri divided by N. So if this is N, the N is here 12 months, then this is also 12. Okay, so this is how you make an average return from a year of stock. So if you have already this R or K, yeah, for a year, Then back again to our previous example of average return in economic condition. So yeah, you just measuring for every condition for this K bar or R bar over here. Okay, so this is the same with this here. So this is the up, yeah. So this is the same. Right. Now, what about the risk, the standard deviation? The standard deviation also comes from, again, this is the average formula, yeah? So the standard deviation here, or sigma over here, is just Ri minus R bar for all of the I, yeah, for all of the month, divided with the number of months minus 1. So just like this. Why this standard deviation is minus 1? Because you see, we want to calculate the difference from the second one with the first, third one with the second, fourth one with the third, etc. But the difference between 1 to, say, 1 to 12, it means there are only 11 differences, right? From 1 to 12, it means there are 11 differences. So that's why in statistics, the standard deviation should be like this, n minus 1. So this is the example of a 7-month returns, yeah, and the question is to calculate the average return and standard deviation from data in the table. Okay, so this is the, well, I write down again over here. So here the month January, February, March, April, May, June, July. Okay, and this is the price. The price is 50, 51, 52, 49, 48, 49, and 51. Now the return. Okay, I will call it as the K, R. Right, remember the capital gain from the price, the return from the price is PT divided with PT minus 1. Okay, so now the return over here, return of January means price from December the year before divided with price of January today, right? Minus 1. Do we have the data of the December price from the previous year? No. So just nothing, none. Right? Now, the R of February is P January divided with P February minus 1 is 50, 50 divided by 50 minus 1 is so this is 0.02. So I write here as 0.02. Okay, and then the return for March is price of March. Oh, my mistake over here, yeah. It should be here. Sorry. It should be sorry, this should be February and this is January. So for March is March divided with February. minus 1. So it is 52 divided with 51 minus 1. It is again 0.02. Am I correct? Yeah, almost the same. Yeah, 196 actually. 0.02. And this become minus 0.06. Okay, and this one minus 0.02, and this is 0.02, and this is 0.04, right? Then I add all of this return here. I add, so it becomes the sum of the return here is the I, yeah, 127. So this is 0.02. Okay, so the average of return for the whole 7 months is sigma return I divided with n. So 0.02 divided with 7 is 0.003. Oh, sorry, my mistake. This is not 7. It's actually 6. Yeah. So 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. So this is 6. So 0.02 divided by 3 is 0.006. Okay. Now. Okay, so this is first the return. Now we want to calculate the risk. What about the risk? Remember that the risk should be through the standard deviation, and it has the standard deviation. I'll write down here. Standard deviation is like this: square all root of r minus r bar quadrat divided with by n minus 1. Yeah, and this is the sum. Okay. Wow, sorry. It should be Ri minus r bar square root of, oh sorry, square, and this is the sum of I to n, yeah, divided with n minus 1. Okay, just go back because I have a very small whiteboard over here, so I cannot clearly writing on this white slide, not whiteboard. Okay, so now what we have to do is we do here Ri minus r bar, yeah, and do it directly quadrat. So here to make the calculation over here, yeah, Ri minus r bar, so this is no Ri, and 0.02 minus 0.06 here, 0.06 quadrat. How much is that? 0.02 minus 0.006 quadrat is 1.96 power 10 to the minus 4. Okay, and again here, oh, luckily we have the same number here. no, 0.6 square. It's also 1.96, 10 over the minus 4. And this is now minus 0.06. So it's okay, yeah, if it is minus. I forgot to mention about the minus over here. So if this is plus and this is minus, it means that minus is lost, period. Okay, so we just have lost. So you see, here 49, the previous one is 52, so we have lost. Big deal. It's okay. Don't be feel that weird if you see the negative value here. Right, 0.06 minus 0.06 minus 0.006 square is 2.916. 10 minus 3. Where the minus go? Where is the minus go? Where did the minus go? The minus go because it's square over here. Minus times minus is plus. Okay? Right. Now. Right. Minus 0.02 minus 0.006 square is not 6.76 times 10 to the minus 4. And then here 1, 2, 3, 4, 5 here. The 50 0. Luckily it is also the same with this, the first and the second. So I just copying the right. And last but not least here 0.06 square is 1.16 10 to the minus 3. Right, I will erase the right side here so I have more space to my writing stuff here. Okay, now you see here this is 10 over minus 4, 10 over minus 4, here minus 3, and here also minus 3. So to make it quick, yeah, well, I'll just put it here. One to make it to make it with the same factor of 10 over minus 4 here. So I'll change these things with 29.16 10 to the minus 4. Yeah, 2.916 10 to minus 3 is the same with this. Okay, so this is also 6.76 10 to the minus 4, 1.96 10 to the minus 4, and here also 11.6. So we change, change here again. Now I added, okay, I added this guys, so this is the same factor, so we can just write here. Now I just add 1.96 plus 1.96 plus 29.16 plus 6.76 plus 1.96 plus 11.6. This is a very long calculation, so we have to be careful with this. 1.96, 1.96, 29, 6.1. So you calculate along with me, yeah? So it is 53.4, 53.4, 10 to the minus 4. So this is the sum of Ri minus R bar square of it. This is I1 to 6. Okay, now I'll change the slide first. So now after we got the R minus the sum of Ri minus R bar the sum of 6. 1 to the 6 are I minus R bar square, and this is the risk, yeah, standard deviation of square root of these guys divided by n minus 1, remember? And our n is 6. If n is 6. Okay, now I change this with n then. Right now here, because we have already calculated our first denominator over here, so this is the square root of 53.4 10 to the minus 4 divided by n is 6, 6 minus 1 is 5. So then 53.4 times 10 minus 4, yep, divided by 5 is equal with 1.068 10 to the minus 3. So this is the risk, or we can say as 0.0001 here, 1 2 3, yes, 0.68, like this. Yeah, so the risk, the return, the average return, the average return is, for that 7 month is 0.00606, or how many percent is this? 0.6%, right? Yeah, with the risk for 0.001068, or 0. How much percent it will be? Percent per 100. 0.1068%. Okay, so what does it mean? The average return is 0.6%. The investor can have a return, maximum return of 0.6% plus 0.1068%. So that will be 0.068%. So this is the maximum profit, and it will have loss for minus here. So this is what we call with risk here, the minus over here. See? Okay. 68% is 0.6 minus 0.1068 0. So they might get 0.49% of return, yeah, because it might lose for minus 0.1068, and also it can reach the maximum return by adding with the standard deviation. So that's why we call it a deviation from the average return. So that's the risk. The risk, and also the profit if it is plus, yeah. Okay, understood?